Hello and welcome to another exam paper walkthrough. Today we are looking at the GCSE half papers for Edexcel. Today we're looking at set 4A and we're looking at paper 2F, the calculator paper. So we'll go through this fairly quickly. I'll do a page and then we'll mark it afterwards. So question 1 was simplify 3 times by A times by 5 times by B. So the only real bit that we can simplify here is the 3 times by the 5. So 3 times by 5 would give you 15, and we can also get rid of the multiplication sign, so we would call it 15AB. So 15AB. For question 2, what percentage of the shape is shaded? So realistically, we need to work out how many squares there are. So we've got 10 squares in total, and 4 of them are shaded. So what percentage? 4 out of 10 is the same as 40 out of 100, so it would be 40% of the shape is shaded. Write your answer to part A as a decimal. Well, 4 out of 10 as a decimal or is 0.4, so we go 0.4. And that's it for that page. I don't have a copy of the mark scheme to hand, so I'm bringing it up on a separate screen, and we're looking at 15A is B1 mark, 40 is a B1 mark, and 0.4 is a B mark. So we are looking at B1, B1, B1. So B1, oh gosh, no, I want that one, B1, B1, B1. Let's move that back if we can. There we go, B1. Okay, question 3. Here are some words that can be used to describe the probability that an event will happen. We've got certain, impossible, likely, unlikely, and even. Write down the word that best describes the probability that you will win a raffle when 400 tickets are sold and you have 10 of them. So I would say 10 out of, well, your probability of winning is 10 out of 400, which is the same as 1 out of 100. No, it's not. It's the same as 1 out of 40. So how would I describe 1 out of 40? I would say very unlikely, but not impossible. So I would go unlikely. Part 2, you will get a 10 when you roll an ordinary dice. So there are no 10s on an ordinary dice. That one would be impossible. And then Ashley is making a fair 8-sided spinner. The spinner already has the colours red, white and blue on it. The probability that the spinner lands on a red is 1/2. The probability that the spinner lands on blue is less than the probability that the spinner lands on white. Complete the spinner. So probability of it landing on red is 1/2. So we need half of the sections to be red. So I'm just going to go red, red, red. So now I've got 4 out of 8 red. And then the probability that it lands on blue is less than the probability it lands on white. So we need to have more white sections than blue sections. So we can't go white and white because then, we can't go white and blue because then they will be even. So we've got to go white and white. So we need to have added 3 red sections and 2 white sections. And that's it for that page. That's not going to let me do that. Right. So let's have a look. Just trying to get these pages aligned so I can actually look at one and write on the other. It's not working very well. Okay, so we are looking at, I really want to be able to see what type of marks they are. So unlikely, impossible, 3 marked red, 2 marked white. So we all B marks. So B1, 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 B1. And then 2 B1s, B1 for the reds, B1s for the whites. Okay, question 4 then. So the length of a bus is 10 meters. Gurjit makes a model of the bus. He uses a scale of 1 centimeter to 40 centimeters. Work out the length of the model of the bus. So we're using, in effect, a scale of 1 to 40 centimeters. It doesn't really matter. It's 1 to 40. So this is model to real life. So I'll go M to L is 1 to 40. So 1 centimeter on the model will be 40 centimeters in real life. So we want to look at 10 meters. Well, there are 100 meters in a centimeter. So I'm going to times that by 100 to find out how many centimeters that's going to be. So that's going to be 4,000 centimeters. And if we're using a scale to get from there to there, I need to times by, I've put too many zeros in on there. So 1 to 4,000. We've got 4,000 centimeters is equal to 10 meters. So I'm times by 100 there. So I need to times by 100 there. So it would be equal to 100 centimeters or 1 meter. I don't feel like I've done that right. I haven't done that right. So for some reason, I'm not quite sure why, I said that 10 times by 100 was 4,000. 10 times by 100 is 1,000. So to get from 40 to 1,000, other way around of viewing that is what is 40 divided by 1,000? It's going to be 25. So over here, I should have times by 25. Silly mistake. Good, glad that I spotted it. So it's going to be 25 centimeters. So let's change that there, 25. Apologies for the mistake there. So I'm going 25. Okay, question 5. Michael writes down 4 different factors of 60. He adds the 4 factors together. He will get a number greater than 20 but less than 35. What 4 factors could he have written down? So I'm going to try and keep it simple. I'm going to write down the factors of 60 as pairs. I'm going to have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's all my factor pairs. He adds, okay, so I just need to pick 4 factors that are going to have a total of less than 20, but more than 20, but less than 35. So in effect, I'm going to go, you can pick whichever 4 you want, really. If I pick those 3, they currently add up to 6, so I need a bit number. So those 4 would work, but there's going to be quite a lot of options. So provided you've got 4 factors that are that add up to a number greater than 20 but less than 35, you'll be absolutely fine. A suggested 1, 2, 3, and 15. The mark scheme might have all of them, but I'm going to stick with those for now. Right, let's have a look at the mark scheme then. So we've got 25, M1 for, I'm actually going to zoom this out slightly, I think. I can't do the zoom nice and comfortably, which is a bit of a shame. Right. Let's see whether that helps me out anymore. Okay, so they've gone 25 and they've said 10 divided by 4 is equal to 0.5, or 10 times by 100 divided by 4. So that's the version that I did. So that would have been an M1 over here and then an A1 for 25. And then for the second one, what it actually states is, let's just see. It says M1 for at least 2 factors of 60 clearly identified. Second M1 for 20, the sum of the 4 distinct numbers less than 35. Correct answer only for the final one. Okay, so I'm looking at M1 for my listings. Was it M1? Yeah, M1 followed by M1 and A1. Okay, question 6 then. So Mr. Smith kept a record of the number of absences for each in his class in one term. Here are the results: 0, 0, 0, 8, 4, 5, 5, 3, 2, 1. Right, and the mode. So Mr. Smith kept a record of the number of absences for his class, for students in his class for 1 term. Okay, so these would be, I would assume, weeks or days. Okay, but anyway, write down the mode. So the mode, the one that happens the most is going to be 0. Write down the mean. So in effect, for the mean, you could add them all up and divide by the number of numbers. So if I do this really quickly on my calculator, I don't need to worry about the 3 zeros. So I'm going to do 8 plus 4 plus 5 plus 5 plus 3 plus 2 plus 1. So they add up to 28. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by 10. So I'm looking at 2.8. Right, is that it for that page? It is. So let's have a look at the mark scheme. So the mark scheme said, there we go, mode is 0. So B1 for correct answer. So B1. And then we've got the second one, the sign of adding them up. So M1 and A1 for 2.8. Right, question 7. Okay, Mary works in a maternity unit. She weighs the babies. Total weight of the babies in pounds, but the table shows some weights of the babies in pounds and kilograms. Use this table to draw a conversion graph to change between pounds and kilograms. So I need to zoom out on this a little bit. Oh no, that will do. So I need to put these values in. So 7 kilogram baby was 15.4. So I'm going to put a cross at 15.4. Struggling to read it very well off my graph. I think that's going to be 15.4. Realistically, I could put all the points on. There's nothing wrong with that. I'm going to try and take a shortcut just because I'm a little bit lazy. So 2 is 4.4. And then in effect, I just join them up with a straight line. I'll put a few more in just to show you 3. Oh, actually, it's not going to be a straight line graph. Or is it? Yes, it is. Okay, 3 should have been 6.6. I've put my things in the wrong way. 2 kilograms is 4.6. So I had gone slightly wrong there. 3 is going to be 8.8. 5 is going to be 13.2. No, I've gone wrong. 4 is going to be 11. 5 is going to be 11. Not too high. And then 6 is going to be 13.2. So looking at this, this point looks in the wrong place. Let's just see whether it is or not. It is quite considerably out. I should have gone 4, 8.8. So I've drawn mine too low. So that should have been there. And then I've missed out 3 and 6.6. 3 and 6.6. And then there we go. Now we've got a straight line. We join them up with a ruler, and that's basically our conversion graph. So let's see whether I've got anything rulerish like on my table. May have to do. Or I'll keep the ruler that's in there. That's a bad looking line. Try that again. Again, my ruler isn't particularly good, but there we go. That's my rough conversion graph. I changed £10 into kilograms. So we go at 10, we go up to our graph. And then we go across from our graph. Oh gosh. And then we go across. So I'm looking at, it looks like 4. 8 on my. No, it doesn't. It's less than that. 4.6. So 4.6, 4.5. We'll go 4.6 for now. Change 6.5 kilograms into pounds. So we're going the opposite direction now. So at 6.5, we go across to our graph. When it's hit our graph, we go down. Oops. Five. Go down. Actually, that's my point, isn't it? So my straight line's not very good. My graph should have hit there. So we're looking at just over 14 if we go 14.2. But again, I've not drawn my graph particularly well because I haven't got a ruler. If you use it using a ruler, I'm sure you get much clearer answers. But if we go to the mark scheme for this, what have we got? 2 mark for conversion graph drawn between £4.4 and 15.4 pounds. So that was B2. Let's change to orange for now. B2. And then it is a B1 for any answer between 4.4 and 4.6. So I'm outside of my range. Well, I'm not very accurate there. And then 14.2 B1. Okay. Right, question 8. Henry and Ray buy some flowers for their mother. They buy 3 bunches of roses for £6.99, 1 bunch of roses and 2 bunches of tulips for £4.45. Work out the cost of 1 bunch of tulips. Okay, so I'm going to introduce a bit of algebra here. So I'm going to say that 3 roses, or 3R, is equal to £6.99. And I'm also going to say, although I don't really need it right now, 1R plus 2T, 2 tulips, is equal to £4.45. So R is going to be equal to, if I divide that by 3, I would get £2.33. So in effect, I'm saying £2.33 plus 2 lots of tulips is equal to £4.45. Meaning that 2 lots of tulips are going to be equal to £2. You can use your calculator for this if you want to. £2.12. So I think 1 tulip is going to be £1.06. But I might want to double check some of those workings on my calculator. It looks like I'm right though. So I'm looking at 1.06 there. 1.06. H&R share the total cost of £11.44 in the ratio of 5:3. Work out how much Henry pays and how much Ravi pays. So we're splitting H and R into the ratio 5:3, and the amount that we're splitting is £11.44. So that's split between 3 plus 5. That's split between 8 parts. We'll bring calculator in. £11.44 divided by 8 gives us 1.43 is worth each part. So Henry's part is going to be times by 5. So Henry's going to pay £7.15. And then I could do £1.43 times by 3. All I'm going to do is, just to save me calculating, 1.44 minus the answer that I just brought up. So that would give me £4.29. So Henry gets £7.50, pays £7.15, and Ray pays £4.29. Okay, and then marks for that, where do they come about? So we have got M1 for, okay, there we go. You can kind of see that nicely there. M1 for £6.99 divided by 3, which is 2.33. So we got M1 there. Then we go. Second M1 for second M1 would be picked up kind of here, and then A1 for the £1.06. Right. So Henry and Ray, the Henry and Ray question, we have got £11.44 divided by 8 picks up you the first method mark, and then times that by 5 gives you the second method mark, and then it's an A1 mark for the final answer of both of them. Okay, so question 8, calculate the length of AC. So we're using Pythagoras to find a shorter side. So I'm going to call it x for now. So x squared is going to be equal to 18.6 squared minus 7.2 squared, which is going to be, straight to my calculator, 18.6 squared minus 7.2 squared. Then I'm going to square root my answer. Square root the answer as a decimal would give me x is going to be equal to 17.1499. So to three significant figures, keep missing off my nines. So to three significant figures, that's going to be 17.1. Is that the only one on the page? It is. So what does the mark scheme say? The mark scheme says 17.1. So we've got square, square, and subtract. That gives you the M1 mark. Oops, a daisy. That gives you the M1 mark. And then for square rooting gives you the second M1 mark and giving us 17.1. All right, question 10. Chris has two children, Beth and Amy. So quite nicely, we've got A, B, and C. Beth is 10 years older than Amy. Chris says, I am twice as old as the sum of Beth's age and Amy's age. Chris is 40 years old. How old is Amy? So if we kind of set this up, I'm going to set this up as A, B, and C just because it helps me out. So Beth is 10 years older than Amy. So if Amy is X, then Beth is 10 plus X or X plus 10. And then Chris is twice as old as the sum of their age. So that's two lots of the sum of their age. So that would be 2X plus 10. And then Chris is 40 years old. So if I say that that's going to be equal to 40, so two lots of 2x plus 10 has to be equal to 40. Meaning that if I could multiply out the bracket first, I'm going to halve them both first though. So 2x plus 10 has to be equal to 20. And then minus 10 from both sides, 2x has to be equal to 10. And halve them both, x is going to be equal to 5. So Amy is 5. Okay, mark scheme for that then. It says an M1 for algebraic method to set up Amy and Ben's age as x and x plus 10. So I picked that first method mark up there. It then says for setting up that equal to 40, my M1 there, M1 there. It then says an M1 for first steps of solving, so M1 there, and then A1 for 5. Okay, next question then. So for this one, you're told Joe and Anne buy some fruit from the same shop. Joe buys 4 apples and 3 bananas. Anne buys 3 apples and 4 bananas. Work out the cost of 1 apple and 1 banana. We got 2 spaces. We have, okay. So simultaneous equations, we've kind of done a bit of what simultaneous equations question earlier. So 3a plus 3b, 4a plus 3b is £2.50. I'm actually going to convert them into pence just to help me out. So I'm going to say it's equal to 250. And 3a plus 4b is equal to 240. I'll call that equation 1 and that equation 2. So I need to either have my x coefficients of the same numerical value or my y coefficients. My a coefficients or my b coefficients. I'm going to go for b's just because I like cancelling the middle out best. So I'm going to do equation 1 times by 4. So 16a plus 9b is going to be equal to 250 times by 4. Well, 25 times by 4 is 100. So it would be 100. So it would be 1000. And then for question, I'm then going to take equation 2 and I'm going to times that by 3. And I've made a slight mistake here, which I've spotted. 3 times by 4 is 12, not 16, not 9. So I'm going to times equation 2 by 3 now. So 4 times by 3 is going to be 12a. 3 times by 4 is going to be 12. So again, lots of silly mistakes at the moment. 3 times by 3 would be 9a. 4 times by 3 would be 12b, and that's going to be equal to, times that by 3 now, 24 times by 3 is 4. I'll do the calculator, but I think it's going to be 24, 48, 50, 60, 72, but we'll double check. 420 times by 3 gives us 720. Okay, now I'm going to take one away from the other to get rid of my b coefficients, and I'm going to say that's equation 3 and that's equation 4, and I'm going to do equation 3 minus equation 4. That gives me 9 take away 3 would be 6a is going to be equal to 720 take away 240 is going to be 480. So a is going to be equal to 480 divided by 6, 80. So each apple is 80 pence. Pardon? Oh, great point. Yeah. So 16a take away 9a would be 7a. Another silly mistake there. So let's try that again. 480 divided by 7 would give us not a very nice answer. Let's just double check. Right, it's just that I've made a mistake. Let's see if I can spot where the mistake has come from. Right, times by 4. 4 times 4 is 16. 3 times by 4 is 12. 250 times by 4 is 1,000. Feel like I'm going a little bit loopy. Times by 4 is 1,000. So I agree with that. Times the second one by 3. 3 times 3 is 9a. 4 times 3 is 12. 240 times by 3, 720. Can't spot it yet. That doesn't look right. There we go. 1,000 minus that is 280. There we go. That makes sense. My little brain can rest easy. 280 divided by 7 then. 280 divided by 7 gives us 40. And then substitute that value for A into one of my initial equations. In this case, I'm going to substitute it into equation 1. So 4 lots of A becomes 4 times 40. So that would be 160 plus 3B is equal to 250. So 3B has got to be equal to 90. So B has got to be equal to 30. So I've got A is 40, B is 30. Can do a quick check if I wanted to. My quick check would be substitute those values into the second equation. So check with equation 2. So 3 lots of A would be 120. Pen's going on the fritz. Plus 4 lots of B, which would be 120. And they both add up to 240. So yeah, I'm right. In terms of mark scheme for that, then it is B1 for correct equations expressed. So I can pick up my first B mark just for writing those 2 equations down. So I would call that a process mark, but I'm not going to argue with them. M1 for complete method to eliminate. So that's M1. M1 for correct substitution of the variable, so M1, so A1, M1, A1 for my 5 marks. Okay, and then next question. Just see, last question as well. Right, Neville saw this car for sale. He got a 25% discount off the price of the car. He paid 7,200 for the car. Work out the price of the car before the discount. So 25% discount means that he only paid for that value. Well, 25% discount would be paying for 75% of the original amount, which would be a multiplier of 0.75. So if I want to find the original price, 7,200 divided by 0.75, and I type that into my calculator and press equals. 7,200 divided by 0.75 gives me the value 9,600. Okay, and where do we fit on that? So it is okay, slightly interesting. They're saying 3. Interesting mark scheme. A1 for 9,600, A1 for 9,600. So I think I would award an M1 for identifying what the multiplier would be, an M1 for the actual division, and then an A1 for the answer, which I've written there to get me the marks for that paper. Okay, if anyone is watching this, just to make it clear, you have got all of the topics by question there at the end of the mark scheme. I'll put the mark scheme along with the work solutions onto the Teams channel, along with the recording of the video. Thank you very much for taking part, and I shall stop the recording.